Welcome to The Explainer. Today, we're going to pull back the curtain on a concept that's the absolute powerhouse behind almost every transportation choice model you'll ever build: maximum likelihood estimation. Seriously, if you really want to get why your models work the way they do, this is for you.
So, let's start with a problem that's bread and butter for transportation engineers. How do people decide to get from A to B? You've got data, travel times, costs, all that good stuff for each option. The big question is, how do we build a model that actually explains why somebody chooses their car over the bus or the train over their car?
Now, your first thought might be, hey, I'll just use a linear regression model. But you've got to pump the brakes on that idea. It's just not the right tool for the job. See, we're modeling a choice, which means our answer has to be a probability, a number between 0 and 1. A linear model, it doesn't have those boundaries. It can give you completely absurd predictions, like a negative 20% chance of taking the bus. And that just doesn't make any sense. It's a huge red flag that we need something else.
Okay, so here's our game plan. First, we're going to really nail down why we need a special tool for this. Then we'll get into the main event, the likelihood principle. After that, we'll see how to apply it directly to Logit models, and we'll wrap up by figuring out how to tell if our model is any good in the first place.
All right, first up, modeling people's choices. Let's get super clear on why the old standbys, like linear regression, just completely fall apart when you're dealing with discrete choices.
And this is the whole story, right here. A linear model just tries to draw a straight line through everything. But a Logit model, it's much smarter. It uses this elegant S-shaped curve. And that curve is key, because it has a natural floor at 0 and a ceiling at 1. It's got guardrails built in, guaranteeing that our predictions always make sense as probabilities. It was literally designed for this exact kind of problem.
Okay, so that brings us to the engine room, the thing that actually makes these choice models go. It's a really powerful idea, and once it clicks, it's actually super intuitive. It's called the likelihood principle. This quote just nails it. This is the entire philosophy behind maximum likelihood estimation, or MLE. Instead of asking, what does my model predict, MLE totally flips the script. It asks, look at the real-world data I have, the choices people actually made. What model parameters would make that reality the most probable outcome? It's a beautiful reversal of the question.
The best way to think about the likelihood function is as a scoring system. Imagine you're testing out different model parameters, like maybe people really hate travel time but don't care about cost. For every combination you try, this function gives you a score. And that score is the probability of seeing the data you actually collected. Our whole goal is to just tweak those parameters over and over until we find the combination that gives us the absolute highest score.
So the whole process really breaks down into 3 pretty logical steps. First, you pick your model framework, say a multinomial Logit, with its unknown beta coefficients. Second, you build that likelihood function, our scoring system, based on your model and your data. And third, you unleash the computer to find the exact set of betas that gets you that high score. Now, here's a little pro tip, a practical shortcut we almost always use. The thing is, when you multiply thousands of small probabilities together, you get astronomically tiny numbers that can cause computer errors. So, what do? We take the logarithm. It's a neat mathematical trick that turns all that multiplication into simple addition, which computers are way better at. And because of how logs work, finding the maximum of the log likelihood gives you the exact same answer as maximizing the original. It just makes the math way easier.
All right, so theory is great, but let's get our hands dirty. How do we take this powerful idea and actually apply it to our transportation choice problem? It's time to connect the dots.
Let's be super clear about this. For the kinds of discrete choice models you're going to be building, like the multinomial Logit, MLE isn't just an option. It's not one of many choices. It is the fundamental, standard way we estimate the beta coefficients that are the guts of your model.
So you've got your survey data, right? It probably looks a lot like this. You've got each person, the different options they had, the attributes for each of those options, like time and cost, and then the most important part, what they actually did, the choice they made.
So what's MLE actually doing with all this? It's on a hunt. It's searching for the magic numbers, the beta for time, the beta for cost, that, when you plug them into your Logit formula, make the choices we see in this table the most believable, the most probable story. It's all about finding the parameters that best explain the reality you observed.
Now, this is really important to get. You cannot solve this problem with a pen and paper. There's no clean, simple equation. This is where we rely on software. I want you to picture a hiker on a huge, foggy mountain. The hiker's altitude is the log likelihood value. The algorithm is their guide, telling them, take a step in this direction. They check their altitude. Did it go up? Great. Okay, now take another step in this new uphill direction. And it just keeps doing that, step after step, until it can't go any higher. That's when it knows it's found the peak, the maximum likelihood.
But listen, just because the computer found the peak of the mountain doesn't mean our work is done. Once that algorithm spits out the best model, we have to step back and ask a really important question. Right? Exactly. How do we actually know if this model is a useful description of the world or if it's just, statistical garbage? We need some yardsticks. We need metrics to judge our model's fitness. So, if you're coming from the world of linear regression, you're probably thinking, where's my R-squared? Well, for Logit models, we have what are called pseudo-R-squared measures. McFadden's is a popular one. It basically tells you how much better your fancy model is compared to a totally naive model that doesn't use any variables at all. Then you have others, like McKelvey-Zavouina's, which is a bit more theoretical. It tries to get at how well your model explains the unobservable desire for an option that's going on inside someone's head.
And there are other tools in the toolbox too. Percent correctly predicted is as simple as it sounds. How many times did the model guess right? But when you're comparing different versions of your model, AIC and BIC are your best friends. They're awesome because they reward the model for fitting the data well, but they also penalize it for being too complex. They help you find that sweet spot, preventing you from just throwing variables at the wall and overfitting your data.
Okay, wow, that was a whirlwind tour of maximum likelihood estimation. So let's just take a breath and bring it all home with the key things you need to remember. Look, if you remember just 3 things, make it these. First, the core idea of MLE is simple. It works backward from reality. Find the model that makes what you saw most plausible. Second, this isn't some obscure theory. It's the engine in the driver's seat of the choice models you use every single day. And third, and this is crucial, don't just run the model and walk away. You have to be a critic. Always evaluate its fitness using multiple metrics.
And that really brings us to the final and maybe most important point. Getting the software to spit out some beta coefficients, that's just the first step. That's the mechanical part. The real work, the real value for you as a modeler is what comes next. Taking those numbers and interpreting what they actually tell you about why people make the choices they do and how you can use that knowledge to shape better transportation policy for everyone.